Hello everybody to the third Elyra and CLAIMED community call in 2023. Please note that Elyra and CLAIMED are two separate projects, but they share some properties and also some of the core people. That's why at the moment we have this joint call. Today I want to show you how to start using the CLAIMED C3 compiler. The CLAIMED C3 compiler is a compiler which takes Python code, R code, and notebooks and creates different assets out of it. So it creates common workflow language tasks, and it creates Kubeflow pipeline components, and it creates Kubernetes jobs at the moment. Obviously, you can extend it. For example, Airflow might be one of the next targets, but nevertheless, let's get started with this boilerplate. So we have created a boilerplate to make it super simple for you to start your own CLAIMED-based project. The idea is the following. So let me actually show you two slides. Okay, so the idea is that you can remain in Python or R space wherever you are familiar with, and you forget about everything like Docker files, YAML files, and so on. So you keep writing your Python scripts or you keep writing your R scripts, and then the compiler will create artifacts for you. We call those operators, and you can see here that the blue thing is that what you create, and the green thing is what the compiler creates. So it creates a CWL task, a common workflow language task, and also a Kubernetes job YAML at the moment, and a Kubeflow pipeline component YAML. And obviously it creates also the Docker file and the Docker image, and it installs all the requirements in that Docker image, and it pushes it to registry, and it's referenced from all those three artifacts again. What you need to provide as well is a common workflow language workflow description, and you just pull in those common workflow language tasks and create a workflow. And that's how you develop your workflow locally. So in that case, you can use your local machine. You can even debug, and at a later stage, you can take this CWL workflow and compile it into a Kubernetes pipeline. And then you can obviously scale it. I will skip some other features of the compiler. For example, it can use a decorator pattern to, maybe I have the slide here. It's here. Yeah, just one sentence. It's a decorator pattern, and it allows for parallelization. But maybe we can keep that for another session, because I just wanted to introduce the boilerplate to you. So let's actually go back to the boilerplate. And obviously, since you want to code something, we can just fork boilerplate, and I'll delete that later. So I just call it boilerplate. And then I can just check it out.
I think the screen share just went down.
Oh, okay.
Looks
when
like
did it went down? Just now?
like a few seconds ago.
Okay. Thanks so much. Otherwise, I would have ruined
It's back. Yeah.
Okay. I would have ruined the recording. Okay. So so what I've done is I've just forked the boilerplate, and now I'm checking or pulling it to a local environment. So, oh, I messed it up. 1 second. So, okay. So what we now need to do is we basically we can follow the README. So we are working in a local virtual environment, which we create now. Okay, then we activate it. I think I can even create a script, but I thought it's quite nice that you see the individual steps to know what's going on. And now we need to install two tools. One is the claimed suite. No, that's the claimed compiler and the CLI. Oh, sorry, copy that one. And the other one is CWL tool. So CWL is an open standard, common workflow language, and CWL tool is the reference implementation. It's used for local development. There are different compilers and execution environments for it, including Airflow. I'm not sure how mature this is, but it's interesting. Okay, this will take some time. Just checking if I'm in power mode. Oh, I'm in balance. Let's go to performance. Okay, good. So now we see the into operators, and let's actually just have a look at one of the source code files. So this is this one here. This is a Python script. So what you need to have is a doc string to describe what you're doing. The name of the operator is basically the file later. Then your dependencies. We have active issue open in the compiler that you can also specify a pip install -r requirements.txt. Then you define the interface via environment variables. So this is an example of a string. This is an example of a string with a default value. So that's an optional value. This is an example of an integer, and this is an output. But at the moment, outputs are not properly handled. That's something we still need to take care of. But yeah, now what we can do is we can create the operator. So there's a create operator command now. And in reality, it would already push to the registry. But what we do now is we have here test mode, and then we skip the push to the registry. So what happens here is you see here we have created claimed example operator container image containing all the dependencies. In that case, it's only NumPy. We also auto increment the number, the version number. So whenever you change the code, you have a different version number, and that gets automatically reflected in the deployment descriptors. So here for Kubernetes job, here for Kubernetes for a Kubeflow pipeline component, and here also in the CWL task, it's also reflect. I'm wondering why there's no 0.4. I need to double check that. It should be 0.4. Anyway, so what we can do now is we can just try it out. So in CWL, you can directly run the tasks. You don't need a workflow just for testing. That's quite handy. And you see here, it's actually working. So that's the output. Because we created 23 random values. If we only create 3, then we only see 3. And then you can directly use it from a workflow. So this one is already prepared. So you have here example operator and example operator. It's just run twice. So if we go back and go into the workflows directory and we say CWL tool, you can actually just use our command and replace it by the workflow. And now we should see the output twice. So first step, second step. So that's the single source of truth. And that way we can develop locally and debug locally with all the logs at hand. No, that's quite nice if you're used to debug stuff on OpenShift or Kubernetes. And one last thing I just wanted to mention in this task, in this CWL task, we are actually using the claimed CLI as base command. No? So it's just making use of stuff we already have, because we actually not only create 3 things from each Python file, we create 4 things, because you can also execute each operator from the command line. Yeah, that concludes my presentation. You have any questions? Additions, commands, complaints? I can also stop the recording if you feel more comfortable.
No, Romeo, just as you mentioned, I can definitely see the intersection there with Airflow type ducks,
Yeah. Okay. Yeah, I think we need to wait
target,
for. Yeah, we need to talk to Luciano next week.
Yeah.
When he's back, I think that would greatly solve the problem of the lack of developers from the Elyra side. No, we can use the developers we have to make Elyra stable for CWL, and then keep that code separated and just let call Elyra claimed. That's my proposal. Let's see what Luciano says.
Yeah,
Good.
absolutely.
Okay. So, anything else from your side?
No, that's it.
Perfect. Yeah, then thanks for joining. I'll share the recording and then maybe see you next week.
Have a good weekend.
Bye.
See
Yeah,
you.
you too. Thank you.
Bye.
Bye.